In a previous video, we looked at iterators and generators in JavaScript, but we didn't get to look at the async version of iterators and generators. So in this video, we're going to take a look at async generators specifically, how we can create them, and also some of the built-in Node.js libraries that use them. We'll start by writing an async function here. And remember, we're going to use function star, which means this is a generator. We're going to go with another contrived example. We're just going to look at natural numbers. All right, so we're going to allow you to set an optional max that defaults to infinity. So this could be an iterator that goes on forever. And we'll set num equal to 0. And then while num is less than max, yield num, and then do num plus equals 1. And so this is a basic async iterator, right? There's not really much going on here. What we've really done is taken a synchronous iterator and we've just tagged async on the beginning of it. A more interesting thing that we could do here is actually to yield a promise. And in the case of a static value like this, we could just wrap this in promise.resolve, but that's not particularly interesting. Maybe a better thing to do here would be to actually use the asynchronous nature of this generator and introduce some timeouts. Let's import set timeout. If you use the global set timeout in JavaScript, this is kind of similar, but actually a fair bit different too. You can see that first of all, this returns a promise of t, which is the value. So we're not necessarily passing a function to set timeout. Also, the delay is the first argument instead of the last. So what we could do here then is say set timeout, and let's use the num as its own delay. So we'll delay 1 millisecond, we'll delay 2 milliseconds, and so on. If we take a look at the type that is being inferred here, we can see that this is an async generator of number, which is great. Set timeout is going to return a number because that's what num is. Just to be clear, if we change this to like a string, or maybe we just did a string of num, then this would infer an async generator of string. So that's what's going on there. All right, so now let's create an instance of this generator. And now we can use a for await loop to iterate over an asynchronous generator or an asynchronous iterator. Remember that generator implements both iterator and iterable. So we can use a for loop to iterate over it, but we can't use a regular for loop. We have to use a for await loop. So we can say constant num of whole numbers here. And the reason I'm using TypeScript here is so that we can see kind of how some of these things work together. So we can understand what these values actually are. So remember, whole number is our async generator. Now num is just a number, right? Because we're using a for await loop, we're actually able to unwrap that. Now you might think if we pull out the await here and just use a normal for loop, then maybe num would be a promise of num. But actually that's not how that works. Notice the error that we get here. Async generator must have a symbol iterator method that returns an iterator. Remember, symbol iterator we looked at last time, and that's what returns the iterator. Async generator does not have that. Async generator actually, and we can see this in action, async generator has symbol.async iterator. Symbol.async iterator is just like symbol iterator, except that it needs to return an async iterator, of course, and not an iterator. If we look at the type of x here, we can see that x is a function that returns the generator. And of course, generator implements iterator. So that's what's going on there. Okay, so let's add our await back in and actually see this in action. I'm using a library called TSX, which is not TypeScript in JSX. It is a TypeScript executor. And so we can run our example file and look at that. We are getting a lot of numbers and it does seem to be slowing down. It's not slowing down super fast. So here's what I'm going to do. We'll be able to see this a little better if we just multiply the num by 1,000 here so that we get an additional second delay with each number, right? So let's do this. So we get 1, and then if we wait 1, 2, we get 2, 1, 2, 3, we get 3, 1, 2, 3, 4, we get 4. I'm counting too fast, but you get the idea. We can see how this gets slower each time. That is a basic async generator. And of course, instead of yielding a kind of useless value like this, you can imagine a situation where you have promises that you're working with. Now, a great way to use async generators is to consume other async generators, maybe ones that you're getting from a third-party library or the standard library. And so let's take a look at an example of an async generator that comes with the standard library, and that is glob. We can get glob from node.fs/promises. Glob allows us to pass a pattern and it returns a list of files that match that pattern, kind of like you would do on the command line. So for example, if I did ls source star.ts, you can see we have 3 files in here. This pattern right here, source/star.ts, is a glob. And so let's actually use that. Here's what we're going to do. We can actually create our generator. I'm going to create it in line here. We'll just use glob. Let's go up a directory here, and then let's go to common/source star.ts. So we're not using our whole numbers here anymore. This argument is still called num, but that's fine. If we actually look at it, we'll see that now it's a string. And what we should be printing out is some file names. So let's rerun this. You can see we have a list of file names being printed out here, things that are in the common directory. Okay, so let's write our own generator that consumes the glob function. You can imagine that if we're operating over a set of files here, we probably want to read that file. So let's also import the read file. This is going to take a path, of course, and return a promise of a buffer. Before we get to the generator, let's create a basic function that can do this. We'll call read file to string, and maybe it takes a file path, and we can just return here read file, and we're going to take that file path. Let's just pass UDF8 as the second argument there, and then when we get the buffer out of that, we can do buff.toString. All right, so there's a basic function that can basically convert our file path into the string contents of that file. Now what we want to do is be able to map over this async iterator, essentially, right? And call this on each file. Unfortunately, there isn't a map method on async iterators just yet. There is a proposal for async iterator helpers that is currently in stage 2. And you can see that it includes a lot of kind of like array style helpers like map and filter and take, reduce, etc. And these are going to be for async iterators. Recently, TypeScript added support for the iterator helpers, which are similar helpers. As we can see, if we look at this one, yeah, we got map and filter and take here, but these are just for normal synchronous iterators. The async ones are a separate proposal, but it's actually not too hard to write a map function ourselves. So that's what we're going to do here. Create an async function that we'll call map async. And the first argument here is going to be an async iterable. Let's say that we need some generics here. We're going to take an iterable of type T, and we're going to return an iterable of type U. So that means we're going to need a function that takes a value of T and returns a U. And we'll let TypeScript infer the correct response type there. But this is actually pretty easy, right? Because we already know we have this for_await structure that we can use. So we can say for_await const value of iter, and now we have our value. Notice if we look at the type of value, you can see we have an awaited T, which is perfect. That's exactly what we want. Then we can yield our function of value. And there we go. It's really that simple. We're just going to loop over our first iterator and yield based on our transformer function here. And so now what we can do is create a generator of our file contents by using our read file to string to map our glob through our map function. So let's give this a try here. I'm going to pull out our glob here, and we can say file paths, and then let's do paths and content. A map async. We'll pass it the file paths as the first argument. And second, we'll pass a function here that takes the path, and we want to return a tuple of the path, and then let's await our read file to string, and we will pass it the path there as well. And for TypeScript, I'm going to throw an as_const after this. Ignoring the linting errors, we can see that paths and content now is a generator of a tuple of a string and a string. We could loop over paths and content, and we could get the path and the content. Right? We can destructure those out, and actually let's print them as an object so we can see the value of each. There we go. You can see each file here. We can see we have the path and we have the content. If we scroll up to the top of this one, path and content. And so this is how we can create generator utilities like map here. You can see if you're familiar with working with promises and you're familiar with synchronous generators, async generators aren't really that much more complicated. Things do get weird when you want to try and start combining multiple async iterators together. For example, if you want to like multiplex multiple async iterators together, that can get weird. This is actually something that's built into Deno. Deno has something called a mux async iterable, which allows you to pass it multiple async iterators and kind of like interweave those together into a single async iterator. It's pretty tricky, and one of the cool things about Deno, though, is that you can just take a look at the source code directly. So, for example, we can look right here at, what is it? Is it the mod.ts file? Let's see. Yeah, here's the class right here that is the mux async iterable. And so if you're interested in playing more with async iterables, I think that is a fun place to start. Let me show you one last trick before we close it up for today, and that is that you can use array.fromAsync to convert an async iterable into an array. We could do here paths and content. If we log this array here, think about for a second what's going to show up. Well, of course, it's a pending promise because I got that wrong, but let me throw an await in there, and it's an empty array. Is that what you expected? Remember, async iterables, just like normal iterables or normal generators, are consumable. And so we've already consumed paths and content right here. So let me comment out that for loop. And now you can see we have our array. I hope this gives you a little taste of the value of async generators. I'm hoping to create some more videos on async generators in more practical use cases soon, but this was kind of a high level look at how they operate, how they work. I think you can probably see any place where you have almost like a stream of data that you need to process sequentially is a great fit for something like an async generator. That could be anything from keystrokes coming from a keyboard or clicks from a user in a website, or it could also be incoming requests on a webhook or to a web server. So there's lots of ways you can use async generators. We'll explore some of them in the future. Thank you guys so much for watching, and I will see you soon.